Hello, hello, hello. You have reached Saturday Science Chats. Hello, hello, hello. I'm here. I'm glad to see people lining up in the green room. If you want to come in and talk with us live, you can. That's what we are here. We're going to hopefully be here almost every week. I've got a new schedule kind of lining up. Been busy like a lot of people, but certainly welcoming you to come and join us. All you have to do is go to this URL, type that into your browser, live.naturalphilosophy.org, and you can come into our what I call a green room, and you can come up and talk. Today's subject is really interesting. We're not only going to talk about constants, but anything. Can aliens on other planets come up with the same things we're coming up here? What do you think is a joke that no one except we strange earthlings came up with? And what are the things that we really think that are so universal that if there were aliens out there, they would be finding the same thing? So that is our topic for today. But of course, you've reached Saturday Science Chat, sponsored by the John Chappell Natural Philosophy Society and in conjunction with the Dissident Science. And like I said, today, the panel discussion, are constants arbitrary? But even more than that, what in science is universal? Make sure you do, though, if you're watching this and you really like these, please subscribe, hit the like button. Those kinds of things help. We're over 1,000. We're coming up to 1,100 subscribers on John Chappell, the John Chappell YouTube channel. And of course, we are past 4,500 subscribers on Dissonance Science. I want to thank all of you who have subscribed to watch this. I know a lot of people can't watch it. If you're in Australia right now, I think it's midnight or 1 a.m. So, thankfully the Pacific's really wide, so we can kind of make it so that's the worst time to see this live. But the rest of it, Europe and around the world, we welcome everybody. So going to be, like I said, real interesting discussion today. But if you do want to join us, just type in live.naturalphilosophy.org. So what else? You want to check us out on our websites. We have our community on naturalphilosophy.org. And you can go there. It's kind of like a Facebook community. Sign up, start talking about subjects with like-minded people who are not afraid to question the origins of any of our theories. And that's the way it always should be. We should be able to say and think and challenge anything. You should be able to go to any university and say, I'm going to write my thesis on how the Big Bang is wrong. And they should go, oh, where, Johnny, that's so great. Why don't you do that? Well, unfortunately, we're not quite there yet, but we have good news is we got a lot of people out there, tens of thousands of people that we know of that are what we call critical thinkers, and they're just a really amazing group of people. To me, that's where I'd want to be, and so you can check out that community. But if you're new to this, you can go to beyondmainstream.org, and that's our online magazine for critical thinkers. So if you don't understand, wait, what are you talking about? Particle physics could be all screwed up. What do you mean quantum mechanics could be wrong? What do you mean the Big Bang could be wrong? What do you mean relativity could be wrong? All these things that we talk about. Well, go and check it out. We try to write that magazine so that people come by and can read about it in a more colloquial, not technical way, and get your interest, hopefully. And we also have a wiki, which has over 10,000 web pages of scientists, abstracts, and concepts, etc. And if you want to add your work to it, you just contact me, and we'll get you out there, and that would be great. So we also have our memberships, and I want to thank all our members who are monthly and annual members. Of course, we do donations as well, but if you want to become a monthly or annual contributor, you can and go to membership.philosophy.org. But I guess I was ahead of myself. We do have one. What's going to be happening with this is every other Saturday, I'm able to be here. I've checked that out, my schedule. So I'll be here with myself and Dissident Science. That means we're going to have a combined audience. We're going to talk more about general topics because that's the kind of thing I like to try to get so people who, like science can come in and won't be blown away. On the other Saturdays, we've been having some alternative groups out there, and I'm hoping that we can get them on the other Saturdays. It's going to be more technical stuff. So people who are into really the technical stuff, where there's going to be more equations, but much more heavy duty stuff. I think that'd be a good way to split this up. So I'm hoping to get that going, and we are starting something new. It's not really new. I've been doing this for the last 6 or 7 years, is having an annual fundraiser. And the reason is we just, even with our memberships, and I appreciate all the members, we're still not paying the bills. And I do have a list of all the things that we need to pay for. So this is not like, just, oh, we need money, not tell you how it is. So what I'm trying to do here is to get us into a better place financially. And you can go to fund.naturalphilosophy.org. This is not a membership. This is not a reoccurring thing. We've already got, I'm trying to get $3,000. I know some people out there have more disposable income, and we've had a number of people like that already contribute, and I greatly appreciate them. I won't name them here, but they are named there. They can choose to do that. But I do want to thank the people who have donated generously. Really, really appreciate it. You don't know how much I appreciate that and how important that is. So if you can give as little as $10. You can give as much as $1,000. And we do have donors in all of those ranges. But instead of making this kind of a private affair where I kind of do fundraising like a politician from DC, I'm open this up, and hopefully we can get there. Because if we get this money, we'll be able to breathe a lot easier. So this is the reason why we're doing it. Our memberships don't pay all our annual expenses, so we need to constantly solicit individual donors. I've been doing that, but again, please. I'm not poo-pooing in any way anybody who's giving $35 a year. Every dollar counts. We do need to have breathing room. I want to do lifetime achievement certificates and frames that are really nice. We've done that before, but by the time we get the certificates, pretty cheap to make, but the frame is not really cheap because we want to give a nice one, and then we have to ship it. So I want to give out lifetime achievement awards regularly now because we have so many people. We've actually had people pass on, like Dr. Edward Dowdy, who I really regret not having given a lifetime achievement award. But it's not easy to run this organization in these times, and it's really just been too stressful, constantly living on the edge. I just don't want to stress out with this. I'm figuring, well, we either want to support this community or we don't. I'm being completely transparent as to, how much that we're needing. And of course, really, before we had really no problems because our main money makers were our annual proceedings and also our in-person conferences. We could, and some of those, we got our bank up for quite, literally in the tens of thousands of dollars. So that was really, really great. But times have changed. People coming together, people having income to fly out and spend a week at a place. It's been very limited. We started in 2015 reviving that, but the number of people coming out to those events was quite anywhere from about 15 to 20 counting over the whole time. And we basically just barely paid for what the event was because we have it in a place and we have expenses for that, et cetera, et cetera. So it's just not the same. It's a different world. I'm not exactly sure why. Maybe people here may have some idea, but anyways, it's still definitely worth it. And the world, to give you an example, the world changing. I work for LexisNexis company. I'm in the supercomputing group. I'm working in the area of human language and computers. And we have a very nice building here in Boca Raton. And I have a cube sitting there. And we would go there and be with everybody. And then when the pandemic hit, everybody started working at home. And now that place is almost empty. People have got used to working at home. There's a lot of advantages. My dad here, he's not been great. I can take care of him. So it's just not the same. I wish it was. I wish people had, the disposable income, and also the cost of things has just climbed constantly. Unfortunately, we don't have a society where we have a maximum wage, which I think we should. I think the most you can make should be $10 million a year. If you can't be happy on $10 million a year, you can't be happy ever. But I won't get into all that. I'm sure people are here screaming at me right now. But I think, that's part of it is just the people in our society not having that disposable income that they used to have. So, And the other thing, I think it's just getting used to it. Once you get used to not having to travel, and we do this constantly, we're constantly giving papers. It's like we're having a conference every Saturday. So, in that sense, I think this is, really, really more the way the future is. So, don't knock it. I do want to give you. This is what the CNPS provides. Our community-friendly website with Buddy Boss. That's not cheap. That's not cheap at all. Our website and web expenses are really everything. And, we have, of course, these monthly discussions, weekly and monthly discussions. We have our latex publishing for publishing books and papers over Leaf. When we do our proceedings, maybe we should do those, but maybe do them less frequently. That's not a bad idea, because we can do it online now and put them all together. We have our email blast, so we have, MailChimp, with almost 1,000 people we send out every week, every time we do one of these. We have our web, beyond mainstream website, and of course our wiki. These things are all things going. But really the biggest thing is to have this thing that we're doing now. It used to be cheap because there weren't many people doing it. But once people realized everybody wants this, everything became a service. It used to be servers were cheaper, all the software was cheaper, et cetera, et cetera, et cetera. If you don't believe me, here's our monthly expenses. MailChimp's $26, Overleaf's $30. Server security. First of all, that's not a monthly expense. That's an annual expense. So that's service security. So you can zap that one, but these two are here. The server is coming up in December, $750. Now that sounds like a lot, but that's annual. So you can divide that by monthly, and that's pretty good. Our Buddy Boss is the Facebook-like stuff. Server security. People go, why do you need that? I mean, that's annually. Well, it's because we've been hacked. Because of our going against mainstream, we had been hacked numerous times. In fact, we had, for 3 years, we couldn't get somebody off of our server. They were literally sending stuff. And then that's why sometimes people contact me, says, Dave, I go to naturalphilosophy.org and my browser's saying it's a dangerous site. Well, it was a dangerous site in the beginning because people hijacked it. It was anonymous from Brazil. I know, because they actually told me. With banners they put up on there, Anonymous Brazil's hacked your website. So we've had that. So we now have to pay. Well, we paid $300. In fact, we had they did catch something this last month, and still, even our other sites get spammed and everything. We have our membership press that is just to have our memberships and all that automated. It's $250 a year. StreamYard, which is really cheap. That's the most amazing thing. For $200 a year, we can have just unlimited use of this StreamYard, which is just fantastic. It's just fantastic. And a secure certificate. Oh, I don't want to go to your website because all these things add up. So about $2,800 in total. So again, if you can, please, I'm going to put that up here. Please think about making a donation. If you are a senior person who has some cash, and that once a year we are a not-for-profit organization. We are not a 501(c)(3). We are a different organization that is not for profit. So you can write it off. But please, if we can get up to $3,000 by the end of this year, that's going to help us have breathing room and allow us to finally have I'm going to honor somebody from our society as a lifetime member, and I'm going to pay $75 every time I do that to send something out, because our bank account is just always constantly needing a fund. So please consider that. And I do, again, appreciate it. I'm going to talk to some people I know, some of our donors, to see if I can get them to donate. But again, thank you so much for those people who have donated. I know I see some of the people that are here have done that. Greatly appreciate it. So I was thinking to myself, somebody was, I think it was Alexander Unsker was talking about it. If you haven't checked him out, go to Alexander Unsker. I think it's the Machian on YouTube, and great channel. He's been on I've interviewed him several times. We're pretty good buddies, and he wrote what I consider one of the best books out there against physics, the problems in physics, and that's called The Higgs Fake by Alexander Unsker. If you haven't read it, you should. the Higgs fake, and you will be totally amazed about how poorly science is done, engineering is done, software is done in particle accelerators. The way they pretend to find stuff is inexcusable. There's nobody policing this. No one's gone there. I mean, we should have some international science society go there. And I think after 4 hours of talking with the way they pretend to find things, it would be completely found out to be a joke. It's not using the scientific method. It's very bad. So if you haven't read about that, please check out Alexander Unster's book. The book, he says to me privately that he wished he would never written because it kind of tainted him. But now his YouTube channel is going well. I think he's coming up to 15,000 people, and he does some. But when I saw that, he was talking about constants. So, are the constants we have in science arbitrary? Are they universal? And other things. We're going to also talk about it because are certain things in science also universal? What have we discovered that is universal? The constants. Many are arbitrary, some are universal. Just imagine, this way I thought of it, if we were to think of another intelligent race somewhere, we always have this idea that they got super brains and all that stuff. Anyways, regardless, would they come up with something like the Big Bang? I hope not. Well, who knows? Would they come up with something like relativity, the atomic structure, atoms, the periodic table? I'm not going to make my thoughts known here. Particle physics, the way we have particle physics. Plate tectonics, because maybe they're on a place that they have plate tectonics. And that's the idea, well, that's not conversation. Yes, it is, if you believe the Earth is expanding and other things in the universe are expanding. Have other people discovered that? And of course, our mathematics. As you know, we've had many people on here, and myself, I've got a Bachelor of Science in mathematics. I love math, but math, the real number system, is flawed. The universe has no negative numbers, so that's why we have square root of -1 and the imaginary numbers and stuff. So what do we have in the human race that we could confidently, at an internationally galactic council, come up and says, yes, we've discovered these things and we are not embarrassed by them? I think that's pretty interesting. So, those are, and if you look at that, let's just look at the fundamental constants before. This is just to give some background for people before I open up to discussion. But, if you look up in Wikipedia, there are a number of fundamental physical constants in the physical theory, except it's fundamental. This is where, if you haven't seen Alexander Unster's interview with David so-and-so, I can't remember his last name, but he's American, who won the Nobel Prize for supposedly getting these independent fundamental constants down to 4. I don't remember. And the conversation's just great. You should just look it up. Again, Alexander Unster and David. He starts out really, pontificating like he's some genius guy, and then Alexander Unster the whole time's kind of looking at him with this quizzy look. He's got 2 cameras, by the way, and he's like going on, and as he asks questions, the guy says, Alexander Unster would come back at him with real fundamental questions. He started going, wait a minute, this isn't just an interview to let me pontificate about how smart I am. And he came back with really poignant questions, and the guy started getting really uncomfortable until the end. He's literally took off his mic and was holding it in his hand, was totally frustrated. And so, again, this whole thing of these, what Alexander Unster calls arbitrary packages with arbitrary variables. And that's what we really have. They were quite arbitrary. So it says right here, there is, however, no single correct way of enumerating them, and it is a matter of arbitrary choice which quantifies are considered fundamental, which are derived. So this is very interesting. So is the gravitational constant, is that going to be something that at a universal, intergalactic science conference? Hey, that's pretty cool. Just made that up. Intergalactic science conference. Would we be able to talk about? Everybody would know. Oh yeah, the gravitational constant, the speed of light, Planck constant, the Yukawa couplings for quarks. Oh my gosh, no offense, folks. Can you believe I would go to this intergalactic conference and just apologize profusely for we human beings for science, but again, that's my opinion. Two parameters of the Higgs field. Jeez. 4 parameters for the quark mixing matrix. Seriously, can you imagine the United States? You imagine the Earth, human beings having a booth at the intergalactic science conference and trying to explain these things to people? I mean, it would be kind of really, really funny. Anyways, all of these things. But anyways, let's open it up to questions. If you have any questions or want to come up here and talk, absolutely. I don't want to, I don't have a lot to say about this. Again, if you want to come online, you can. Let me just put that up there live. So if you want to come and join us, you can type in live.naturalphilosophy.org. And, I'd like to get the conversation started. Also, if you're in the comments, make a comment and I will put it up here. Really hope this is going to be participatory, folks. But I've got some people in the green room. Want to wave your hand? Somebody in the green room, pick one of these constants. I can pick one, but I don't want to be the person today. So what constant would you say at an intergalactic science fair conference that we would be very certain to find other people with that constant? Anybody? I'm going to bring somebody up. Come on, Ian. Is there one that you would know? Can you come up and speak about this? I'm going to bring you up anyways. Hey, Ian, how are you?
Very well, thank you, David.
So which one of those? What would be the safest constant that you would imagine if we were at this intergalactic science conference that you would be very certain that other beings in the universe would have found?
Well, I first thought actually of the speed of light, although I hesitated because it would appear maybe that I was sort of acquiescing to modern ideas. But I'm basically an etherist, and I consider perhaps an all-pervading medium rather than a vacuum, inhabiting the universe, and probably the constants, the magnetic and electric constants, are the same throughout the universe. Well, if that's so, then the speed of light would be the same everywhere. Well, one is not certain of that. The other one would be the gravitational constant, but then there is the possibility that it varies throughout the universe. Probably not, but there is that possibility.
Yeah, I think one of the things about the speed of light, actually, there was a guy in the 2015 conference. I was talking with Nick about this, and he presented a very intriguing presentation on the speed of light slowing down during the last 400 years. That he had statistically shown, statistically significant significance that when we started measuring the speed of light 400 years ago, that slowly it has been slowing down. You notice that when you look at the speed of light from an historical sense, that the speed of light was 300,000 kilometers a second, and then slowly went to 299, and it went down from there. And what he had shown, gosh, I got to find him. I think we have a video of that. And I wasn't really convinced that necessarily that could be true. But then when I saw what people claim is that when you look at the speed of light and we've measured it very infrequently. So it's just a matter of going from bad, crude measuring engineering ways of measuring it to very precise, less precise to more precise, and with that we got, instead of the 300, it was too high. But the problem is that they actually measured the speed of light multiple times, way more than people think, and then when you take all of those together, you see a statistically significant amount that the speed of light here on Earth measuring it was slowing down statistically. So, I mean, you think that's a possibility, or is that a local phenomenon? I mean, when you talk about not, because you said one thing you made me was curious is you said the speed of light would be, I'm not certain it would be universal. Is that because maybe in your sense with an ether model that light would have different speeds at different parts of the universe?
Yes, I think one has to keep that possibility open, that the ether, if you like to use that term, would have different properties in different parts of the universe. Now, there's no evidence for that, but that's a possibility. And the second possibility is the one you were mentioning, I think, David, that it could be time dependent, that, because of certain evolution of the universe or whatever. These properties could change. Now, I'm not sure of that. I think, I'd almost work on the basis that neither of those propositions is true, that these things are universal. For example, measuring different speeds of light, I would say that we're measuring the speed of light from a terrestrial point of view, and the Earth is moving, and you have to make some certain corrections because of the tidal effect of whether the ether is totally earthbound or not, and because of its spin. That's why I think there may be a difference between the measured values, which is not actually absolute. But we don't really know. It's an area of science that would be quite fruitful to engage in. I'm just putting forward the possibility that maybe these things are not universal.
Yeah, I guess it could be though. Some sense we're kind of asking us a wrong question because that's why I think I agree with you. A lot of the constants that we have really are local, right? It's local to what we're doing, and it's I think is kind of what you're saying a little bit, right? I mean, if we're doing it here on the Earth and we're measuring it, how do we measure it somewhere else? Is there going to be a difference? Depends on the model that we're imagining, but it's really hard for us in mainstream science for us to, get even question those kinds of things in mainstream science. And I don't know. It's a fascinating a problem. Now, you were also mentioning the gravitational constant G, and I think they kind of seem linked in some sense because if you have a physical model for a gravitonic model or you have an ether model that's gravity's part of, we seem to always go back to the model more than we do the constant. The constant would come. Is that kind of the idea, or you get that sign of? I'm trying to kind of look at your mindset. Does that make sense? That I know you don't like models though. But then you talk about, well, I'm kind of an etherist, so I'm kind of mixed up. But let's say there's a model for it. There's a physicality that we can describe for either ether or gravity. And it seems like those constants are going to kind of come out of that and give us an idea. Is that going to be, the same, 100 billion light years from here?
Yes, I mean your point is pertinent about the model, because maybe something like G over C squared is a universal constant. Not G itself and not C itself. Things like that come out in certain certain equations and transformations and so on. But I think we're really just speculating. Here, David, we don't really have any firm data. We haven't even done some of these basic experiments in outer space, and I think there's been a predisposition not to do that. So for example, the well-known thing is when it was suggested by people like Carl Zapfi that NASA should do a Michelson-Morley type experiment in outer space. They just ignored him. They cut him off. So we're really quite in the dark here, I think, and we're speculating. Of course, needless to say, the units are arbitrary. The units we use are related to the shape of the length of the human body and so on, a yard and a meter, this sort of thing. So they wouldn't have values like that. What we call large values or small values would not necessarily be so in other parts of the universe. But that's, I suppose, a given. That's the units rather than the quantities themselves.
Yeah, yeah, I believe that's obviously true. They're going to have different, a meter comes from where we are and that kind of thing. So, I know people are complaining about my mic, so I apologize about that. I've turned it down quite a bit. So hopefully that is better. So please let me know. I've been having those mic checks. I've got to do that ahead of time. I mean, it's really annoying. I've listened to them. Better mic? Okay. Thank you guys. So if you do have some questions and things, please feel free. All right. If you have any other ideas or, what about Planck's constant?
I was just going to say that just before I left. Yes, Planck's constant.
Yeah. What do you think?
Quite possibly that would be at the same level as C and G, that we talked about. And it's been talked about natural units. That you might make C equal to unity, for example, rather than a meter and a second and so on. And maybe Planck's constant could be a fundamental constant with regard to energy transitions or you know,
But
atomic.
well, the actual Planck's constant itself, I guess, would be kind of, we obviously numbers, that gets into to whether or not even the mathematical system's going to be the same. Are they going to be smarter than us so that they don't create a flawed mathematical system like we have, with the square root of -1? But are the fundamentals of Planck's constant such that people around the universe would come across this same kind of number, or what we call a constant, something that seems to be important. I mean, where we get it, but is it the case that it's because of what we think how the universe works, or is it truly fundamental?
My guess, for what it's worth, probably worth very little, is that it would rank in the same triad, if you like, as the speed of light, gravitational constant, and perhaps Planck's constant on the smaller scale. That would be my guess, that these would be fundamental. But some of the other things that maybe you did scoff a little at them, understandably. I'm not. I think they're probably inventions of modern. Complete fabrication of ideas. I think they're unlikely to be fundamental constants.
Oh
Yes, you have.
yeah, yeah. Yeah, the Yukawa couplings for quarks and leptons. The two parameters of the Higgs field potential. Four parameters for quark mixing and mixing matrix. Three coupling constants for gauge groups. I mean, no, these would, I would be very embarrassed to be at our booth in the intergalactic science fair. I would kind of hide these.
Right. And it's interesting. I'd forgotten this, but actually, the first three are the very ones we're talking about. So
Yeah,
I suppose,
exactly.
the gravitational constant was worked out hundreds of years ago, maybe by Cavendish or, even earlier, the concept in Newtonian ideas. The speed of light, I suppose it was realized that it wasn't infinite, maybe in the 19th century, or perhaps actually earlier than that, perhaps the 17th century astronomically. But again, it's hundreds of years old. The Planck constant is maybe just over 100 years old that was conceived. They're all they're not things that have occurred in the last 50 years, let's say.
Right, right. Yeah, the last 50 years, I think we've just gone off the rails a little bit. I mean, and I think part of it, again, again, I keep harping out, read the Higgs fake, folks. When you read the Higgs fake, you realize how they can do what they do. I mean, basically, they predict X. They've got noise, mostly noise, and then they then filter out for that noise as if they found it, filter out everything out but that noise. And then once they get that, then they go to the next step and do the exact same thing. So it's literally a house of cards. So, but yeah, it's interesting. Planck's constant is, I don't know. I don't know. It is quite a interesting idea that are we discovering what the universe is? I mean, one of the things is too, my father always says the universe doesn't care about any of this, right? The universe isn't like, well, some people believe it's got a conscience or whatever, but I mean all of these things that we are looking at, yeah, I think we live in this part of the universe. If you believe in infinitely up and down, that is, there's no ultimate particle and there's no ultimate large structure, then in our area of the universe, in more of a vertical area, these things, gravitational constant, speed of light, Planck constant, are going to be interesting. But okay, all right. Thank you so much. I'm going to
Thank you, David.
bring that down and see if we got other people. We have Nick. Hey, Nick, he's back. Hey, Nick, how you doing? I can't hear you. You are muted, and that would be terrible because I'm sure you have many things to say. So,
Yes, I went away, but the conversation was so interesting that I came back here. Regarding the speed of light, well, like you, I'm really a believer in the model versus a lot of abstract math. So what I think of the speed of light, well, that's a physical phenomenon.
right.
So I would think that it must depend on the physical environment.
Mhm.
And in fact, people derived it from the permeability and the permittivity, which
Mhm.
are physical parameters of the environment that it's in.
Mhm.
So I can appreciate that the speed of light may well change over time
Mhm.
because the nature of the universe is always changing,
Mhm.
and also that it might change from uh, location to location. But when we speak of the speed of light, we are always saying in vacuo, in a vacuum.
Right.
So that would make it if on Jupiter or another galaxy they measured it in a vacuum, they'd be measuring it in the same um, type of environment, unless something like the strength of the local gravitational field affected it. Um, So the speed of light in a vacuum might be a constant throughout the universe. But then again, it appears to be changing, decreasing slightly over time.
Yeah, but in some sense, is there a true vacuum in reality, right?
Well, that's a
What
good
is,
point.
that's
Yeah.
really because when we're assuming a vacuum, we still think radio electromagnetic waves still go through that, right? I mean, even the vacuum of space. And one of the things I thought of is in some sense, I agree. I'm a person that believes that everything's physical and that it all kinds comes from that. And I think this thing that this one the scientist, I'm gonna have to find his name when somebody's talking. I'll do some research, but he gave a talk in 2015 here in at our conference, the CNPS conference, and he statistically showed again that the speed of light. I talked about that. Now, if you have a model for light and gravity and all that, there's perhaps an explanation of why. Well, there should be, right? If you have a model, you should be able to say why that kind of thing would be happening. Some people would be, some people would have it with an ether model, and that ether, like Ian was saying, that ether would be of different densities. So maybe what's happening, the Earth is gaining mass because it's expanding. If the Earth is expanding and gaining mass, this gaining of mass will change what ether could be. The ether density or whatever, that would somehow change the velocity of light. But it's, again, if you have a model, and that kind of gets me to another question, is that is, you know, would models be one of the things that let me see if I can get back here. I've got a slide here. Yeah, I'm going to bring this up. here's an interesting thing is what in this, I think if I look at this, there's one thing here that I see. It's actually more I really think the periodic table and atomic structure in some sense should be, I think we have more evidence for the periodic table than anything. Does anybody agree with that? Yes, no? Agree room? Um, Again, how about in the chat? James Keene, you want to come up here and talk a bit? Wave, hello. James Keene. I'm going to bring him up, see if he can. Hey, James.
Hi, Dave.
Hey.
As a preface, I'd like to reinforce a point that you made in a previous chapter of this Saturday about mainstream physicists not accepting basic scientific method. And I'm trying to paraphrase what you were saying. That really, I think this gets down to a question of morality and honesty of people. And so that in the context, so I'd like to reinforce the direction you were going when you stated that a couple of weeks ago, that in the context of how we might convince mainstream physicists of certain of our critical thinking points that we're making here every Saturday, that it really comes down to, I don't think we can convince them until their morality and integrity as human beings is uplifted. It's almost a spiritual question of character development and the lack thereof, which is the barrier. And so I'm really putting in my own words and further reinforcing a point that you made, David, several sessions ago.
Yeah, and what's interesting though too is there's another person who says something about this, and he has been saying this for many years, and that's Glenn Borchert. Glenn Borchert says that these cycles that we go through in society, that we get to a point where the entire society is at a breaking point where no one accepts anything more, that and that when you get to these places is when these kinds of paradigm shifts happen, where you think to yourselves, it's almost like when human beings get into a point where they are life and death, all of a sudden, all the esoteric, all these little things and kind of questionable things get like thrown out. I mean, they just say, look, this is garbage. They've been talking about this stuff. There's no proof. We've never used the things that they talk about right? How many things in the last 30 years in particle physics has resulted in some technological advance? Nothing. Even quantum computers are really not using quantum mechanics. They're just using another idea that you can make computers without zeros and ones. You can make with states. So when I think you're right in the sense that has to change within that society. That is, a younger generation has to come along and say, this isn't right. All these questions we have are really questions. They're not these things that we're taught. When you go to the university and you question, when you go close to the speed of light, your mass increase, and you raise your hand and ask the teacher goes, yeah, that's a good question. In fact, we should always question those things. That's not what happens. So when is it we get the point? So I think Glenn Borchert's saying is the entire society has to get to this huge breaking point. And he says 2050, that at that point, people are going to step back and just kind of throw out things that are just, and say we got to start over again. So, yeah, I mean, do you have any idea of what that moral change would be, like Glenn is proposing?
Well, like there's so much fakery in the world today, and it's people questioning what is right and wrong. It almost becomes a religious sort of question, religious in the sense of the moral and character development of the child. And even in social psychology, I taught a course on developmental social psychology once. And the moral development of the child is very important. And so when you're trying to say, well, my logic is correct, and the person that you're talking to really doesn't have an integrity, any sense of integrity, they'll just continue to lie for whatever motive they might have, whether it's to continue to get their paycheck or whatever. It's So I thought that you were right on. If I may shift gears and agree with Nick Percival concerning the speed of light and oh nuts! I was talking so much about morality, I forgot my point. Perhaps I'll come back. But one second point that I do recall I wanted to make was about vacuum. I think vacuum is not understood. I think small units of energy, which combine to make the elementary particles that we speak of, such as the proton and the electron, that in the vacuum that we experience, about 88% of the total energy is not in those particles. It's in those small units wafting around. And that is the medium, if you will. So that what my work shows is that vacuum, in fact, is not empty. Is not empty space. You hear about, oh, the atoms, it's mostly empty space. Well, no, it's not, my friends. My work suggests that about almost 90% of the units of energy, I call them quanta, but people don't like to use that term because it has associations in their mind. So today I'm going to just talk about units of energy, tiny units of energy. Hopefully that doesn't have negative associations in people's mind. That most of the vacuum, even in far outer space, is these small units of energy, and which do not, which are not elementary particles like protons or neutrons or electrons. The last point I'd like to make, if I may, is that my work shows that if the density, now we can talk about the energy density of vacuum. If it drops below a certain percentage, the vacuum is opaque, that light doesn't transmit through it at all. This supports the idea that yes, some medium, and it's these small units of energy, is required for the so-called wave transmission of light. So to punctuate my conclusion and to end my comment, when the vacuum energy density is below 0.12, and you have to see my work on that to figure out what the 0.12 means, vacuum is opaque. Light can't get through it. The energy in light actually just disperses to increase the energy density in the vacuum until it reaches a point where then light can actually pass through it. Thank you, David.
Okay, and one thing it seems like you're saying too is if you got to have a kind of in general, this is generality. You got to have some kind of idea of how all this stuff works, some kind of model in your head, so that so that you can even answer a question like, is this a constant? Is this something universal that everybody would look at? So it kind of, one of the questions are we looking at the wrong thing? Would be in an international galactic science conference, are we better off looking at models than we are at constants?
Well, you just reminded me, thank you, Dave, of the point that Nick Percival just made moments ago with regard to the speed of light being an observation. I call all of these constants unexplained observations, and that physicists should be working to develop a model. Yes, you can see my work. I've done that, but others can work on that too. to explain these unexplained observations. It's a misuse of the language to call them fundamental constants, or it's just sort of like saying these observations are taboo, but other observations we're going to use in our science. We're going to go make measurements and we're going to pay attention to those measurements, but and relate them to our theories. But with regard to the so-called fundamental constants, electric charge, speed of light, Planck constant, etc., we're not. They're universal. They're immutable. They are. This is what I call the fundamental physics constants doctrine. And I really was happy to hear Nick Percival say moments ago that these are, I'm paraphrasing now, unexplained observations. Well, he said they're observations. Now I'm adding they're unexplained. And lastly, to conclude, it is my conviction that these particular constants, including the speed of light, gravitation, blah, 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 what we've talked about today, are not fundamental and mathematically can be shown to could not be. Okay, those words are important. Could not be fundamental. Why? Because there are equations relating groups of three of these constants to get one of them. Okay, and you can look these up in any particle physics book. What people are a little bit math impaired because they don't understand what those equations mean. What they mean is that there is redundant information in those constants. Otherwise, you could not say that this constant is equal to subset of other constants on the other side of the equation. What the equations mathematically state, if you have any faith in mathematics at all, is that these are not independent constants. They have redundant information. If the information were not redundant in them, you could not have such equations saying that the speed of light is equal to, blah, 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 blah on the other side of the equation. End of point. Thank you so much. This is very interesting. I was happy to hear Nick Percival's comments as well as from Eon. And
No.
I'll be quiet. I'm talking
No, that's okay. No, it's very interesting. I think it's, when I first came up with this subject, I really realized that we have so many assumptions about constants and models and things. We never step back to try to figure out what are we talking about. And I think we ourselves are guilty of making these into, rock solid laws of the universe. And then when we try to explain them, we start to step back. We start to realize, is it local? I think the other thing too is interesting when you were talking about space and being empty or not. Again, there's Glenn Borchert talks about this in his infinite universe theory, is that you never find space is never empty, space is never full. So it's like you've got that kind of a paradox. But thank you so much for your comments. That was great. So thank you, James. Thank you.
Thank you for the platform.
Okay, thank you. So anybody else in the, raise your hand. Hans, you're waving your hand, and also Nick. All right, let's bring them up. Hey, how are you, Hans? I can't hear you. Let's see.
Yeah, I just clicked my mic on.
Okay. Thank you, Hans, for coming on.
Very nice to hear you again. I'm an old visitor of your site, and I decided to leave the site because I do my communications mostly on ResearchGate. That's also a site where
Right.
people discuss about physics and fundamental physics. And what I did the last 10 years is thinking about a theory that could explain not only the elementary particles, but also cosmology and all those things, the whole universe. And I think I was capable to formulate quite a useful theory. And I'm now about 81, and I captured a nasty disease that hampers me in writing much more and communicating much more. My brain is still working good, but my muscles don't work so good. So I'm hampered in taking part of complicated communications. But I do publish my work still on ResearchGate, where you can publish free and also have it accessed free by other people. And I published my work on the Hubble Book Model project. So if you try to find the Hubble Book Model project on ResearchGate, then you find my latest papers. And my currently latest paper is in English, and it concerns the setbacks of theoretical physics, because theoretical physics has been went many off-roads, and there are still a lot of holes in theoretical physics.
Yes.
And I try to find out why that was so and how it could be done better. I advise you to look at this Hubble Book Model project and to try to read that paper and then say, because everything what is said here is treated there as good as is possible with comprehensible mathematics. It starts with primary school mathematics like summation and counting and multiplication, division, and so on. And I found that number systems have phases and phase transitions. If you go with simple calculations, you stay in the countable world. If you go to all the natural numbers, you end up in infinity, but it's the same number system, but it comes to another phase because you cannot reach infinity in a finite amount of steps. So it is like them going to water, going to ice. You get a phase transition from countable to countable infinity. And there is another one that is if you add all irrational numbers, so you countable is the irrational numbers are still countable with natural numbers, and if you add all irrational numbers, sorry for my language and my speech, it's hampered by my disease, then you get something like a continuum, and that continuum is changeable. If you do that, then you get something that can be described by differential calculus. So mathematics. And David Hilbert and John von Neumann has found a way of turning a vector space into a Hilbert space, and a Hilbert space can store these number systems and manage them and have operators where you can retrieve the data that are archived.
Is there some, Hans, before I'm going to interrupt, because we have try to keep on the topic here now, is people can get at your work by searching your name in ResearchGate, is that correct?
Yeah.
Okay, so I have people in the chat wanting to know. So Hans van,
it's a better search for the Hubble Book Model project. There, all my papers that are relevant are stored.
okay,
And they can retrieve them there.
okay, and are you from Holland, Dutch?
I'm Dutch.
Oh, see my last name? That's from Amsterdam.
Ah, good.
De Hilster.
That's about 100 kilometers from here.
Right. So, okay. Any other comments on universal constants or universal
Well,
in general?
um,
Because people can read about your work, but on the topic of today of the universal constants, what
the
do you have any?
universal constant is in fact the speed of light is universal constant, but it is hidden in a physical unit, meters per second. And meters are measured in physical units, and meters are measured in physical units. So C is has a physical unit. If you wipe off that physical unit, then the constant is one.
Okay.
It is the relation between real numbers and what I call spatial numbers. Spatial numbers are, in fact, what people call imaginary numbers, but I hate that name because imaginary set people on the wrong foot. So I
Yeah,
call them
absolutely.
spatial numbers.
Yeah.
The real numbers, if you square them, you get a positive real number. Imaginary numbers, if you square them, you get a negative real number. And that is the difference between these two numbers. And so they have different arithmetic. And you can combine them. You can combine numbers with one-dimensional spatial numbers, and you get the complex numbers. You can combine them with the three-dimensional spatial numbers, and you get the quaternions.
Yeah. Right.
And
Okay. Okay, I think that's good. That's a good description. So, thank you so much. Again, we're going to keep this on the constants. I did find somebody did make a link to it, and I put that up there. I think it's here. It's the Hilbert Book Model Project, right?
yeah, yeah, that's correct.
Okay. Okay. So I put that link up there so people who are interested can take a look at it. All right.
Yeah, that's
Okay.
nice.
Okay. Thank you very much, Hans, and good luck to your work. I hope people
Yeah, I
will be
was
checking out.
very interested in your approaches, and I learned a lot. You can learn a lot of people that are saying the right thing, but you
Yes.
can also learn a lot from wrong ideas
Yes.
and how to formulate your what you say is formulate better in such a way that you produce
Yes.
a correct theory.
Yes, absolutely. And one of the things about even if you are listening to someone who you disagree with, you always will get your brain will be stimulated
Yeah, yeah.
to help with it. So thank you so much, Hans, and I wish you luck on your work. Okay, thanks for coming on
Thanks
board
for
here.
being here.
Okay, no, thank you. So, really great discussion. It was really great to talk with him. I'm going to bring up another one. I think the periodic table is probably one of the things that I think we're going to find all across the universe. But here's one. This may be easier. What about relativity? Is relativity something that comes about because we get so hung up on the observation of things? Because as Peter Marquardt said, it's a relativity is a theory of event of observation and not of events. It's not a model of the universe. Is relativity because we get everybody in the universe will see that things are relative, and when you measure things, would that be recreated by someone, or is that a really uniquely human construct? Anybody want to try that one on? Everybody's thinking. Okay. Hey, Ian. I mean, isn't that interesting? Oops, you're muted there. Oh, you're still muted. You're still muted. No, 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 no. Muted, muted, muted.
Sorry,
There you
I've been
go.
speaking and you haven't heard what I said. So, yeah, just a bit of pedantry. I like to make a distinction between relativity, classical relativity, Galilean relativity, and special relativity, general relativity. Um, so I'm coming back to just to say quickly that I think classical relativity would be universally conceived and looked at, because it is a real phenomenon. But I mean, the business of SRT and GRT, I mean, to me, that's just a quick fix, to try to explain some seemingly anomalous situation with regard to the transformation of Maxwell's equations, and it's just really something which is what am I trying to think of, like a quick fix. It's not a real phenomenon. It's a contrivance. That's the word, I think.
I always thought to myself, I asked this question a couple of months ago, and I always thought it was fascinating. Like, I think it was on the Einstein's Facebook page, which I go to war there a lot because I actually bring a lot of people this way, because a lot of people think Einstein's got problems. But what if Einstein didn't exist? Would we still have ended up with relativity?
Yeah, I mean, that's a perennial question. Of course, we may put it back further and say, well, something almost identical to special relativity was introduced by Henri Poincaré, maybe at least a year before Einstein did. So maybe the answer is yes, in some form or other. But I still think it's a contrivance, and it would be possible that had Poincaré not introduced it, and even given the work of people like Lorentz and Larmor, that perhaps it wouldn't have been introduced. I think you need a sort of a strange type of mind to accept this, and you do know, of course, David, that it wasn't accepted initially. It was thought quite crazy, and it was only when the media, as you yourself have written about, really got about it, that it got into our minds. Because per se, it's not something that normally would be thought of by an average type of mind, or even an average clever person.
Yeah, and I think also, I think the special relativity, it was kind of, no one knew about it. Special relativity got its fame when general relativity was thrown out there in 1919. Because one of my thesis of relativity is that the Einstein became world famous at that time, became first celebrity scientist ever, first mass media kind of scientist, because he talked about two things everybody understood. Every human being, they know about gravity and they know about light. Everyone knows about that. And the idea that that gravity bent light, the average person on the street who's, is going to understand that. And that kind of blows your mind. And then what happens is, when that blows your mind, then they walk backwards, people, and saying, wow, the universe is crazier than we think. Then they walk backwards to special relativity and they go, well, what does this genius say about that? Oh, as you get close to the speed of light, your mass increases and time slows down. And I think everybody got into the fantasy of it. It was just fantastical. If you look at fiction in the movies and even written fiction, space-time continuum, all of these things, traveling in time, these are massively popular fantasies. And I think that's the problem, is we had this fantasy mesh with relativity, so we became muscle bound, and we'll accept anything. People will say some crazy thing. The thing we hear most, I hear most, and I've got a meme that I put out there about myself, I say, and then people say the universe is crazier than you ever think it would be. Like, Neil deGrasse Tyson, an entertainer and not a scientist. Well, the way I look at it is, the universe isn't paradoxical. It's our theories and models that are paradoxical. The universe isn't paradoxical. And so but we have, in the 20th century, we became very arrogant. We pointed to a urinal, Duchamp, and said that was a sculpture. He didn't do anything, just pointed to it, put it in a show. John Cage came along and wrote a piece for violins to sit on chairs for 4.5 minutes. And everybody marveled at this. So we became muscle bound to accept everything. And I think that's one of the reasons, relativity came along. But I think it's interesting. I'm not so certain myself. I kind of agree with you. Obviously, there's all the things that set up that Einstein came across, right? Einstein didn't come up with a lot of these ideas by himself or in isolation, as people think. But the question is, would another society get caught up in something like this? Or maybe we just would have missed it altogether. I don't know. So, okay.
Yeah.
I know somebody else is waving here. Did you have another
Thank you.
point or? Okay. All right. I'll bring you down here. And next, we've got Nick. Hey, Nick.
Hi. Yeah, I think most societies would not have come up with special relativity. For one thing, I think Lorentz was much more accurate in his model, and that Lorentz, obviously, we can't say that his was the final truth, but to go forward, we are going to have to go backwards from special relativity and go back to Lorentz and then move forward on a very different physical model. And I think another thing about special relativity, and he's saying that creating an observer-centric model and saying that the views of all inertial frames are equally valid, even though they disagree with each other, is the philosophical basis for why the morality of academic physics is flawed, because it's observer centric, and you can't say that anything is wrong. My point of view is equally valid with someone who disagrees with me, so I can just dismiss their disagreement and keep on with my view. So that's an interesting thing. I might make
So,
two more quick
go ahead.
points.
Go ahead.
You talked about Professor Unziker, and the Higgs discovery of the alleged discovery of the Higgs boson won the Nobel Prize. But as Professor Unziker pointed out, the fundamental research was logically flawed. You had tons and tons of data pouring in, and the programs that analyzed this were defined the
Of
Higgs
course.
boson, so they were defined to throw out everything that they thought of as noise, but to accept signals. And you might get a signal that wasn't the boson, but you could say, oh, that's not what I was looking for. But if you analyze tons and tons and tons of data long enough, then you will find what you're looking for. And that was for the super small, the microcosm. But it's interesting that when I read Smoot's book, and he won the Nobel Prize also for looking at cosmology, in his book, Whispers of Time, he followed the exact same thing. In fact, before hearing about Unziker and the Higgs boson, I came up with the same fundamental flaws that Unziker had, but for the macroscopic research model, in that there was tons and tons of data coming in. They had programs that filtered everything out that they were not looking for. And also the mindset was, we were looking for it, so when it shows up, we found it. It's success. It validates what our life work has been about and what our identity is about. And they will only break open the champagne and give you a Nobel Prize for confirming what that particular group is thinking about. So that same exact methodology and flaws in methodology occurs throughout science, from the microscope to the cosmology. And one final point, back to constants. Rather than searching for universal constants, like for the speed of light, we need to find what's the physical model for the speed of light? What's the physics that determines the speed of light?
Yeah, I agree. I mean, some people, I know Ian is not a modelist, but I think that's absolutely essential. And I think at that point, we can say that this is local. We can't really say that necessarily it's universal. because if it was universal, we'd have to have some evidence of that, right? We'd have to go,
Mhm.
100,000 light years in a direction. So it was interesting. I know we have actually, looks like a guy who is more of a physicist. He said, I do want to go off track here a little bit. He says, this guy, Nick, is getting a few things wrong about relativity. Not everything in every inertial frame is disagreed on. Conservation of energy holds as in the same of each frame. Now, here yeah, I know. But here's a couple of
I
here's a
didn't say that. I
I know.
misspoke.
I know. But there's a couple of things here that I have to say. Number one, conservation of energy is a very nebulous thing. Energy is not a real thing. Energy is a concept. So if you're conserving a concept, you can't, that it's hard to say. The other thing is here's the problem with inertial frames that I see. If you're a person like me who believes in an infinite universe where you have, okay, I'm a person, so I can put a reference frame on me, right? Well, how about all the atoms inside me? Okay, there's a reference frame on every electron. Is there a reference frame on every proton and neutron? Those things are moving. Now, if we have quarks and those things are moving as well, you then have an infinite amount of reference frames, and time or something would be different. Again, that's just the problem is the fundamentals of relativity. That is, the physics is the same as in all inertial frames, right? Well, the problem with that is then when you apply in the speed of light is constant. If you apply these two things together, what you end up with is a contradiction because of time and mass, and those can change because of your inertial frame. Then how is it that the laws of physics are the same still in those? So it gets to be it's just too convoluted. But you were saying that you were misquoted, and how is that?
Well, I didn't say anything about everything is disagreed on.
Right.
I'm
Right.
perfectly aware of the conservation of energy and everything like that.
Yeah.
But I think rather than inertial frames having a special property, what Einstein really did, he was studying the effects of velocity. So by concentrating on inertial frames, he made it easier to come up with a theory, and he got rid of all things that would make it complex, like all forces, because force equals mass times acceleration. And if you're accelerating, you're not in an inertial frame. So it's really sort of a simplification to look at things that are a function of instantaneous velocity.
Yeah, I mean, the defenses people have for it are, I don't know. I think part of the problem when I see people defending, special relativity, and I don't know why they do that. I mean, I was at Stanford Linear Accelerator with a particle experimental physicist from SLAC saying he has to unteach special relativity. And special relativity to them is looked at upon as basically not correct, and that they then talk about other things about the experiment itself. And so when you get arguments defending it, I always notice one thing. They talk about one aspect of it, skip all your objections about it, and always are returned to trying to explain to you what is accepted, right? Here's all the rules and stuff. Oh, they don't, mainstream will not go and answer your objection. What they will constantly do is then just to try to teach you what the truth is, and just kind of be calm about it. And then, I saw that happen with in science. That happens a lot with the gravitational waves. I don't know if you know, there were two Danish physicists when the gravitational waves came out. They took the raw data, looked at it, and said, "This is noise. This is noise." And then when they did that, the people who were in charge of LIGO spent the next 2 years going to Denmark to teach them what is right. They didn't address ever the objection. What they literally said, they spent 2 years and multiple trips to go to these physicists to try to explain the truth to them. They never looked at the objection. And that's what I see a lot of times, even in this group in the chat. I will see people come here and they go, oh, no, no, this is the way it is. But they don't listen to the objections that people put up on them. So, okay.
Well, you talked about SLAC, which again is looking at the microscopic, and Ron Hatch showed that the data from GPS supports the Lorentzian view of a preferred frame and disagrees and disproves special relativity, because there's only one inertial frame where you will get the correct answer from GPS. If you choose another arbitrary, and you just go off into the rivers and whatnot.
Yeah, Dr. Carrazzani, a physicist from Argentina, who was my mentor, he said, and what he found out is you can have a frame of reference anywhere in the universe. You can put it anywhere you want and measure from that. But the idea that there are inertial frames, you have moving mass. That is true. But this idea of a frame is, that's the problem. There are no inertial frames in the universe. And that's, here's I know Andrew here. I'm his disagreement. Inertial frames are something you have in Newtonian physics. No, you don't have inertial frames. You have moving mass. There's no frame there. What's the frame part? It's moving mass. Now, whether or not I don't know. I guess the frame of reference is what I guess a frame would be a coordinate system. So what I need people to tell me is coordinates, inertial frames are something you have in Newtonian physics. You have moving mass in Newtonian physics. You don't have frames.
Right.
And that's the problem. We talk about it and we constantly say that, but all we really do is because the frame, tell me what a frame is. If it's moving mass, then I agree with you. If it's a coordinate system, I don't agree with you. So
yeah, it's an abstract math concept where rather than talking about velocity with respect to such and such a frame, you talk about velocity with respect to the ether or to the Earth's gravitational field or something else physical. Velocity with respect to a physical entity.
Right. Well, I knew when people start talking to me, there's so much to talk about. But
I know.
But I do think it's interesting. I don't know. I'm kind of on the fence that relativity would really be recreated somewhere else in the universe by some intelligent race. I don't think so. I don't. I think you have. But again, I don't know. I wish Einstein didn't exist, and if he didn't, maybe we would have gone. I think it'd be an interesting kind of fictional book. If Einstein didn't exist, where science would have gone, and would we have not gotten into the problems we did? Because one of my claims is that Einstein did something that other scientists before him didn't do, and that is declare laws of the universe and then justify and say how the universe works from them instead of defining those. And that's what when he said physics is the same in inertial frames. That's he told the world. He said the universe is that, and of course that's dangerous when you dictate. Okay, any other comments before I go?
That's it. But this is very interesting. Anytime someone says something, it stirs up lots of comments.
Yes, absolutely. Okay, thank you, Nick. If you are in the green room, pushing all the wrong buttons, of course. If you are in the green room, want to say something, come on, wave your hand. You are available. If you want to come and talk live with us, you can. Again, you can go to live.naturalphilosophy.org. You come into the green room and just wave your hand at me, and you can come on the air and tell me how much I am not correct about this, or people pushing my book or my I haven't talked about that once today. Also, remember, please click on the like button. That helps. If you've been watching this for a while, just click on it. Even if you're not going to stay here, click on it. That says, I like this kind of content where people are actually talking this. I'm not sure anybody else on the planet does this. So please do that. And also subscribe to the channel. If you're on Dissident Science, just subscribe to that. We're here regularly, and also with the CNPS. Please do that. And all right, so the other one is, I think too, we've got lots of them here, is the Big Bang. Is the Big Bang something that in our international or the intergalactic science conference would there be numerous uh, I don't know what you call them, beings, sentient beings that would have come up with the Big Bang? Um, I don't know. Would they see redshift and then they'd all kind of think that? Is this unique to us in our history of the way science went? Um, that's a question. Anybody have any comments on that? I think with the Big Bang obviously was postulated because we see what is quote unquote redshift everywhere we look almost. And the Big Bang has so many logical problems. We've talked about that over and over and over again. I mean, one of the problems is every time we get a new telescope, we see further and we see galaxies in formed astronomical structures that shouldn't be there because of the time. And of course, this whole idea of explosion and increased explosion. Why would an explosion happen at all? I mean, we have gone over and over and over. But do you think that a theory like the Big Bang would be something other sentient beings would come up with? Um, Again, let's see, what else do we have? Particle physics, plate tectonics, mathematics, of course, I think is very much, that's another one I added here. Mathematics, we've talked about a lot. Mathematics is a system where we have the real number system, and we've talked about the problems with the real number system. I mean, one of the things my father and I talk a lot about is there are no negative numbers in the universe. We got somebody talking about it says the Friedman equation may describe the history of the expansion, but it does not address the question of its origin. Its assumption, it assumes expansion without explaining it or without motor. Yeah, I mean, that's one of the problems. We do have to explain why it happens. There's just so crazy ideas like Brahms. The other thing is like parallel universes. Well, we've got parallel universes and they're Brahms, and then when they touch each other, it triggers a Big Bang. I mean, there's just too much absurdity out there. It really is. It's really hard to say. But I think the Big Bang is a big bust. I think a lot of people outside of the mainstream can see that. I remember in 1999, I was at an astronomy club where Dr. Karazani was invited to speak. It turned out that I think Einstein had visited there. It's on Long Island. And in 1999, the amateur astronomers who built their own telescopes and got around and talked about all kinds of theoretical stuff, they had explained redshift as not speed, but some other type of phenomenon with light. And the only ones that I remember them discussing and turned to me and they said, yeah, we've explained all the redshift away, that it's not movement. And the only one we can't seem to get a handle on is between galaxies. And that is the galaxy shifts. And it blows my mind because that's over 20 years ago that amateur astronomers are talking about how none of them believe in the Big Bang. And yet we hear about it. You go to school, they talk about it. The objections rose, and it kind of I've seen when people they're put against the wall, they just say, well, what's a better idea? And of course, an eternal universe is a better idea. And that one I don't see. I really think that the Big Bang eventually, that may be one of the first ones to go away because again, we go into deep space and we're not supposed to see anymore, and we have more and more people coming and more objects that are further. I mean, the universe started out 500,000 years in the beginning of the 20th century. It's moved up to millions of years, then 1 billion years, then 5 billion years, then 10 billion, then 13, and then if you look on Wikipedia, it literally says. The age of the universe changes. They literally change that number by decimal points with 13. I mean, I'm absolutely amazed that number's like 13.78. No, it's now 13.77. So We see another person in the green room. Hey, Jim Morrison, great to see you. Did you want to come up and make a few points here? Yes? I'm going to bring him up anyways. He came in, so I'm going to bring him up. Hey, Jim, how are you?
Hey, how's it going?
Pretty good. So, what do you think about all this? I mean, all these intelligent people in the universe somewhere. How
You got a
much?
couple hours?
How much would you be? I've always said that. If like a extraterrestrial came down and they were much better at knowing about the universe, I would immediately go into my apologetic mode as to how screwed our theories and models are. But I mean, what do you think we have right? What do you think we have wrong?
Well, special relativity, wrong. Big Bang Theory, wrong.
Right? How about
Quantum mechanics, wrong.
right? How about our mathematical system? Is that a good system?
You need a model. You need a model that explains things intuitively and simply.
Right. So when we're talking about the constants in these models, what do you think we have now that would stand the test of time in the intergalactic science fair?
Well, I definitely think that C is not an absolute constant. In fact, Einstein toyed with the idea that it was dependent on the gravitational potential before he went whole hog with his general relativity. And I've been in favor of the model proposed by Cheng-Chuan Su, the local ether model. I've even talked to you about it on this
Right. Yeah.
channel.
Right. I think you gave a presentation, right?
Yes.
Yeah. Check it out, folks. Check Jim Marison on our channel, wherever channel you are, and then so yeah, it comes down to really kind of the model as well. And if you think about it, if you believe in an infinite universe, for instance, up and down levels wise, right? We're only going to come up with models that are going to be maybe. I mean, well, there are some models that describe supposedly what can happen at all the levels, but most of the time our models are going to describe what's kind of local, anyways. So what you're saying is kind of like me, is that maybe what we would more have in an intergalactic discussion panel would be more of what the models we have for the phenomenon we see, more and less of constants or equations or anything really. Is that something you would agree with?
Yes. The constants would fall out if you had the right model.
Yeah, and
they're just proportionality constants, right? I mean,
right.
But as Ian said, and someone else, the speed of light was originally calculated as the ratio of the permittivity and permeability of space,
right?
Which were also known constants. So if those are different in different points in space, then you'll have a different speed of light. The problem is that when Einstein came up with his edict that the speed of light is an absolute constant, and I'm going to change space and time to keep that make it look like it. That's correct. Then everything got screwed up.
Yeah. I mean, that's where, and I think after that point, I think modern physics, like I said, took a bad turn because people all of a sudden started making what the universe is. I think that's one of the biggest mistakes and wrong turns in science, is Einstein dictating those kinds of ideas. And you can kind of see maybe where they're inspired, but again, and then the other thing is too is again, the model is, we talk about space-time, we talk about fields, we talk about gravity, all of these things. We don't really continue to have the problem of physicality. One of the great things about the people in this group is they try to give it physicality, whether it's one of the ether models, whether it's a particle model like my father and I have, whether it's a lattice type of model, whatever it is, people at least are trying to come up with ideas or models that, again, like you said, they should be able to come up with the constants, or they should be able to come up with the answer. One of the things, I guess, that they say the speed of light comes out of the physicality of what an ether is if you're an ethers, right?
Yeah. I mean, again, Sue's model shows that the ether is essentially at rest with the gravitational potential, which falls off as you get farther away from the Earth, and then the sun's gravitational potential takes over, and then the galaxies, and then the local galaxy cluster, and it works. You know, it helps you to understand the Sagnac effect extremely simply. You can picture it with a pond and a stone dropped into the middle of the pond, and a speedboat traveling toward or away from the wave crests that are coming at you. That's all it is. You don't need rotation or anything.
Yeah, yeah. I mean, the idea is to come up with simpler models, right? And I think we have numerous models that are better. It's just that we're not allowed to do that. I think one of the problems, it seems, is that universality is a must in science. They make that a must. That is, once we figure something out, it is the answer. We've discovered the way the universe works. We discovered the secrets of the universe. And when you discover those, if what you discovered, what you say is the secret, turns out to be wrong, then you can't do that. It's like Neil deGrasse Tyson was saying about relativity. He says, well, it's right. Something else that comes along is going to say, oh, relativity breaks down in the middle of black holes in its singularity. Of course, it's absurd. I mean, singularity doesn't exist, but that's what he says. So the idea is that we have to build upon things. We've now found these truths. You cannot question those truths. I mean, if you believe that, I mean, like yourself, don't believe in what were considered to be truths. The Big Bang is right. Relativity is right. Our mathematical system is a perfectly good system. If you question those, then you have to admit, and I'd be curious, would you say then that we get better models, but they're never perfect, meaning we're never going to discover the secret that the universe will have these secrets that will be forever understood by us? Or are we just simply making new models that are better and every model is going to be flawed?
Well, I mean, in terms of modern physics, again, it goes back to relativity. Once you come up with a bad theory and start going down the rabbit hole, you just keep going down the rabbit hole and never come out. And those are the more quote unquote correct theories, string theory or whatever, quantum gravity.
String theory.
But I'd like to make one point about the Big Bang.
Sure, absolutely.
Have you heard of Eric Lerner?
Oh, absolutely. Yes.
He wrote a book, The Big Bang Never Happened. He's been pushing that idea.
Absolutely. I got it. I got it right back here somewhere.
Right. Well, some of those ideas I don't agree with, but
right.
Me too. The whole point is that, as you mentioned, there was the tired light theory, was the alternative explanation for the red shift, cosmological red shift. But nobody's been able to come up with an acceptable physical explanation for it. So, since the Doppler effect was well known and it fit the original observations, it won. And then when they got to z is greater than 1, they quietly shifted to saying it's just the expansion of space, not Doppler, causing the redshift. You didn't know that?
I don't know. I would say, Jim, I can barely even say the expansion of space without wanting to really. Yeah, I want to just like I either want to. Yeah, I mean, I can't believe it's almost like saying something sacrilegious. I mean, to me, the expansion of space, and yet people, I think it really does come down to the 20th century arrogance of man, where we have been able to accept all fantasies, all ideas, everything. We have this
Yeah,
idea
the
that
dissidents
anything,
proposed that they'd be left out of the room.
yeah, yeah, yeah. I mean, but I just think that, it really the psychology, our somebody said, here that when you discover it is wrong, cognitive dissonance arises, right? The problem is that we don't, our emotional side gets in our way. We want the I think the problem is when people want to be right, or people want to be smart. I know that a lot of the students in my film who are going to go to physics place positions. Whoops. That's okay. I've got it. But a lot of people who, the students, they said they would forego truth to get their position. People have to make their living. People have to make sure that, in fact, they are. I'm going to bring you down there. That's all right. Whoops, wrong one. I keep doing that. But yeah, but a lot of the problem is just our emotional side. We don't want to give it up. We're making a living at it. We have been married to it. We think ether is right. We think the particle model is right. We think the lattice model is right. We can't explain or don't want to look at the things that are wrong with it. It's very hard. I think one of the things about you have to kind of have what I think would be an engineering. Oh, I think I put that one up. An engineering attitude towards science. You got to think like my dad does, which is we're lucky to cobble anything kind of together that's vaguely right, and hopefully it's just less wrong than the last thing we've tried. And this idea that we've discovered some key or something like that. I think we just gotta be careful with that. How are we doing on time here? 41. Oh, we still got some time left. So, anyways, again, the idea of this whole talk and in discussion today is what is universal. What is something that we think that the human race has really come up with, that we agree with, and that is correct. I think part of the problem too is we're constantly told it works. There's been a million times. It's been a million. Relativity is tested a million times, and we can just come right back at them and says relativity is flawed a million times. Every time you do a particle accelerator, people say, "Yep, we confirm relativity right." Nope. The beginning part of it you don't, because relativity particle physics confirms without without a doubt that mass does not increase. But how do they get around that? They use kinematic equations, relativistic kinematic equations at the end game, where they're smashing things, and of course all of a sudden neutrinos appear to take away the problem that special relativity has introduced extra energy into the equation. We know what's going wrong with it. But when people say it's shown to be right millions of times, they ignore it. They ignore the mass increase and say, "Oh, it's energy," and then they ignore Karazani's find of the neutrino doesn't exist. That an experiment there's an experiment from 1946 where Buchner and Van de Graaff, the Van de Graaff machine, shows that the electron neutrino doesn't exist. You can repeat that experiment today with radioactive material. No one does it. No one looks at that counter evidence. They just talk about constantly. They repeat incessantly. They will tell you over and over how it's right, but they will not address what is wrong. So let's see here. Anybody else coming just outside? I don't know. Anybody else in the green room want to make any comments here? I know I see Eric Reiter, Reader. I think it's Reader. Eric Reiter. He is, if you haven't checked out his work, that is the quantum mechanics and how that's got a lot of problems. Check out the recording that we have with him. Brilliant work by Eric. I see him in the green room. And I know James Keene has his own model. You should check him out and what he's done. And of course, Nick Percival, who's been on here, has his YouTube channel. And I guess they're doing some other things. I think next week, I'm hoping that Nick and Ian, I'm hoping to get your guys' Alternative Saturdays, which is a lot more heavy duty math and theory, to be hosted here. I know Franklin Hugh can host this. I won't be able to be here. I'm only can be here every other week. So we do want to, hopefully you guys will agree to do that, and we will bring that on for you, and you'll be able to come in for those kinds of discussions, which are really, really great nitty-gritty discussions on relativity, on ether theories and ideas there, logical problems, that kind of thing. But it's much more intense. My goal here is to bring in a bigger audience to try to get ideas that are really interesting, so that the general public would like to hear. So mathematics is another one. Oh, wait a minute. Here he goes. Here we go. Here's a person. If you don't think neutrinos exist, it really begs the question as to what particles. Andrew, you're talking to somebody who's looked at this problem for a long time. I will give you the answer. The answer to the question of neutrinos is the answer is that neutrino detectors are buried underground. They're put into Antarctica, and they are done through that for one very simple reason, and that is that they want to shield neutrino detectors from false hits. And the more they've shielded them, the less neutrinos they found. The other thing is, as well as Karazani points out with neutrino science, is that they use low number statistics. So you have hundreds of thousands of gallons of some type of chemical, something like windshield wiper fluid that they have in a big vat. And from that, in a month, they will carry out a beaker of liquid which contains 30 argon atoms or something like that. And they claim that is proof of neutrinos. Neutrinos detectors get false hits. That's why they shield them. Let me say it again. Neutrino detectors are shielded for false hits, which means this little beaker of liquid that contains, I can't remember, I think it's argon atoms, and each one of them is triggered from a neutrino. Each one of them can be from a false hit. And we're talking about hundreds of thousands of gallons. How many atoms are inside there? And to say that there aren't any argon atoms, that we have the ability to make pure liquids ourselves, it's absurd. And the neutrino, if you look at the neutrino origin, this is the other problem with the neutrino. People do not look at the origin of the neutrino. And when you talk about it, they talk about it by the detection. They don't talk about it. The neutrino was postulated by Pauli, and he, somebody died, made the postulation, and Fermi or somebody went on, and they were going to call it the neutron, but the neutron was taken. They called it the neutrino. They do not exist. They do not exist because the postulation was this: here is radioactive material. Electrons are being ejected from a radioactivity. There's no outside source of anything. It is an unstable atomic situation. So electrons are flying out at up to 0.86 the speed of light, 0.86. And Pauli said, hey, if you have that, and you believe in special relativity, you're going to have to apply special relativity to the speed of an electron. And of course, if electron comes out, and what they do is chemically, we know what happens to bismuth, and it's radioactive, how much energy should be coming out. Energy in the form of heat energy comes out of that, from the electrons. The chemistry balances out perfectly without the neutrino. That is, what we know is sitting there, and the energy being emitted, and the balance of conservation of mass and energy works out 100% without the neutrino. What do? If you apply special relativity, you get what we call the magic energy. You've got to pull away. So what do? They postulated at that time, in the very beginning of what the neutrino was postulated for, a particle that had no mass, no charge. And they can't find them. They couldn't find them forever. And when they shield it, they get less and less. And they use literally low number statistics. Think of what astronomical number of atoms you have in this liquid in the detector up in Canada for neutrinos, that these neutrinos are going to come plowing through and create an argon atom, and you're going to collect them. And that's only because of neutrinos. So neutrino detectors detect something? Of course they do. But they're not neutrinos. Neutrinos are the bad boy of science. And it's kind of like strings to me. So the problem is that people will talk about how they're needed. Without the neutrino, this doesn't balance out. Karazani answered that question. He came up with a set of relativistic equations that are not special relativity. He called them autodynamic equations. When you apply them to nucleus collisions inside of particle accelerators, you take out the mistake, both the conceptual and the mathematical mistake of the two velocities being put together and squared. He shows all the math is on autodynamics.org. Go and check it out. When you do that, the equations fall out to be Newtonian, not relativistic. And when you apply those equations to nucleus collision, no neutrino is needed. Meaning, if you take the mathematics of relativity, remove the magical part of it, that when you go closer to the speed of light, you get more energy, you get more mass, and it becomes Newtonian in the autodynamic equations. The error that Karazani found in relativistic equations are fixed. Then you have nucleus collision happening without the neutrino. I mean, the whole story's there. Now you can ignore the story, or you can sit and you can tell me how it's needed everywhere. Well, here's what I'll do. Put autodynamic equations in for special relativity equations. You don't need the neutrino. Occam's razor, simpler model. So I don't know why people want to cling to it. I mean, a particle that was, yeah, it's just crazy. And again, all the people who think there's neutrinos, you have to explain to me why, if you don't believe in special relativity, you can't believe in the neutrino. The neutrino exists because of special relativity. And that's crazy. So if you believe in special relativity, of course, neutrino away. Neutrino away. But if you believe special relativity wrong, neutrino can't exist. And the problem is that neutrino has been used for the magical part, or for ether. I've seen it used as ether. I've seen it used as gravitons. So, hey, that one little... read your history. Read... well, they don't write it that way. Because, you know what? Here's the answer I got from a neutrino scientist who actually answered me. I said, neutrino doesn't exist because it was postulated to save energy conservation for radioactivity, and when you apply special relativity to the movement. I said, that's where it comes from. Applying special relativity to the movement of electrons coming out of radioactive material. Pauly said, you have to do it. And they go, you know what they said? Oh, that's the old history. They literally said that's not important. They literally said, okay, that's why it even happened. That's not what it is. We just didn't know what was going on. It's like, oh my gosh, I'm sorry. I knew we had to fill some time anyways, because we've kind of run out of our subjects and stuff. Anyways, any other questions here about stuff? Just get me going. Again, people say people won't. People will use it because they are married. They don't want to find truth. If the neutrino doesn't exist, I always tell people, call it something else. If you have ether, don't call it the neutrino. The neutrino doesn't exist. If you're a graviton, you're using the neutrino. Don't call it neutrino. If you have a model, don't use the neutrino. Use another name. Well, I use it because everybody calls it that. It's like strings. Strings wasn't invented. It was a totally mathematical, stupid exercise in one dimension. And now we have people talking about strings. I remember an interview at Caltech with a guy who was one of the original string guys saying that he was embarrassed that people even treated this as real. He said, we came up with this as a mental exercise. We said, this is a joke. We wanted to see if we could make a mathematical model. He says, there's no one-dimensional or two-dimensional anythings. And yet, strings are talked about. And deGrasse Tyson, with string theory, we can solve the problems with special relativity, general relativity at the singularity of a balloon. Yeah, I'm embarrassed. Dear aliens, I'm really embarrassed. The only thing I'm not embarrassed about is the group of people I hang out with in this group and these critical thinkers, the people that we see here. And I applaud everybody here, even if you believe in the neutrino, but you are a critical thinker. I don't care. That's fine. As long as you have the ability to realize that all these things that we've been taught can be all wrong. And that if you do take enough time, I always tell people, take a look at Earth expansion. Take a look at the videos. Take a look at the evidence for it. Don't take my word for it. Take a look at relativity. My dad never took. We went through the entire film. I spent 8 years filming Einstein Wrong, and then at the premiere of Einstein Wrong in the theater, I asked my dad, "Is Einstein wrong?" He says, "I don't know. I haven't checked it out." So what did he do? He checked it out. Next year, he's given a paper on how special relativity is wrong. So don't take our word for it. But you got to be a critical thinker. We got to get to the point where I can go to any university and I can write I can take Carozani's new radium E experiment. That's what he calls it. Do it and show special relativity wrong. I should be able to do that. And if I'm a physics professor, I should say go for it. Because if you show Einstein wrong, that could bring us fame and fortune, even if you're going after fame and fortune. So that's why I've been hanging out with these people, the Borkerts, Nick Percival, James Keane, Jim Marison, Ian Cohen, all these other people that are here in the chat. You are here and you are at least listening. You are at least questioning. Unless we have people coming here to save us. That happens sometimes. They're going to save us. I'm a physicist and I'm going to save you from... You just don't understand. Let me explain it. Of course, when you get to that position, here's the Sagnac effect. Special relativity doesn't work with it. No, let me tell you how special relativity works. They didn't answer your question. Explain the Sagnac effect. Explain why we don't measure mass increase in particle accelerators. It's the place where we should find it mostly. So I applaud everybody here. Everybody who has the ability to be a critical thinker. We have different ideas about it, but if we get together and talk about it, all that kind of stuff. Yeah, this is so true. This is so true. Ed SWL number 7. Neutrinos, dark matter, dark energy are non-existent. These are kludges, people. They are kludges we use because our models suck. And we have a lot of people working on great models. A lot of great people. I know James Keane has his model. I know Nick and Ian talk about ether models. We have Jeff Yee. It's a great model, a Newtonian model. All Newtonian, everything. Even at the subatomic level. He's an etherist. He's got a model. We have Glenn Borkert. He's got the infinite universe model. And he's also an etherist. We got all kinds of really good models out there. So, it's just like, step back, folks. If you find yourself trying to explain why your model's correct to somebody who's got a legitimate criticism, be careful. I still talk to people about ether. Ether's got a container. The only reason there's we have waves in the air here is because we have, it's contained. If you let air out of the space station, you're not going to hear anybody say anything. There'll be some maybe sounds transmitted through the surface, but for things to be transferred through a medium, it's got to be contained. And so, if you're an etherist, you got to deal with that. It's great. My dad and I have to deal with the pinhole problem in our model. We've got we have dispersion. done. There's all kinds of things that each model has problems. Look at the problems. Don't look at what's right and try and ignore them. You got to do that. So, okay, I think we're about done. I do want to thank everybody for the really stimulating conversation. Thanks for the neutrinos so I could get myself out because we were running out of people in the green room of this thing. We had solved everything up to that point. Actually, in 1 hour and 40 minutes, all of the discussion was done. But I'm hoping, folks, to have next week, if we can, an alternative here, only on the CNPS channel. So we'll look for that. I will be putting out all the same things. So if you're part of the Alternative Saturday group and you want to continue presenting and bring it to this here, I'm going to get Franklin Hugh to be able to host it because I think he knows the software pretty well. So look for that. And I'll be here every other week. And please, 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 if you can, do go. I noticed the fundraiser, we're still at the same amount. Please help us out because sincerely, if we don't get enough money to keep our websites and all this going, it's kind of going to just end up being, this kind of discussion with no home. And we really need to have a place where we can keep things and write things. And so please help us out with that. And we'll see you in a couple weeks. And also we'll be doing, with that kind of money, we'll be able to start doing our lifetime awards because they cost like $75, folks, per award. And I've got so many people. There are people here today that are going to receive them, I know. And I want to start giving those out. So look forward to that. But please donate if you can. If you're a person that has some means, $500, $1,000. I know some people out there do have that kind of income. In their older age, they've saved up and they want to spend it on something good. This is definitely a good cause. So, and even if you have $10, help us out. Become a member, pay $5 a month. Those memberships certainly help. They don't cover everything. That's why we're having a fundraiser. So please do it. Hit subscribe button so you'll be alerted to this, and also hit the like button. But thank you so much, everybody, for participating, and let's get out of here. Always remember, people, stay critical, stay thinking. I'm David de Hilster, your science therapist, trying to get you the promised land of becoming a critical thinker. Ciao for now. Thanks to all of you.